Okay, next we're going to do section 4.3, which is problem solving in the pharmacy. So we're going to use ratio and proportion methods to solve story problems. So we're also going to use dimensional analysis to calculate, of course, the drug dose. So when you're trying to solve a calculations problem, you should look at it as if it's a story, so story problems. So you begin by asking, what am I looking for? So what am I trying to find? The answer is usually in weight, expressed in milligrams, and volume expressed in milliliters. Some of that sometimes can change, and when that changes, and you have different ones, you might need to convert first. So you're going to compare the active ingredients in a carrier vehicle to the active ingredients in their vehicles, and a vehicle is an inert medium, such as a syrup in which a drug is administered. So if you look at this right here, you have the active ingredient or the desired ingredient on one side, and you have the active in the vehicle desired. Then what you have on hand, so what active ingredient and what vehicle you have on hand. Or you could also think of what's in stock. Okay. Below you have the desired amount of the drug and the prescriber's order. And over here you could have a ratio of the pharmacy, what it has in stock. So just remember, when setting up proportion, units of the numerators must match and the denominators must match. Sometimes I'll say tops must match, bottoms must match. But here they are, step by step. Now I'm just going to read through this because I like to show people more while I'm doing examples. So I'm just going to read through these steps. Read through the entire problem. One mistake people make is they do not read through the entire problem. They just start plugging numbers in the formula. But you actually want to read through the problem to make sure you don't have to do something else prior to doing the ratio proportion. Identify what the question is asking for. So this becomes the variable x labeled with the unit you are looking for, such as x milligrams or x milliliters. Okay, sorry about that. Step 2 is identify the prescriber's order. So you want to circle the dose ordered by the physician. The step 3 is identify the appropriate stock available in the pharmacy. The on-hand amount is nearly always a ratio, 1 milligram to 1 tablet, or if it's a liquid medication, it may say 125 milligrams per 5 milliliters. So you want to underline this information. This information is sometimes found on the labels of the drugs used in the pharmacies. So by circling and underlining things, you're helping to organize the information before you put it into the problem. So step 4, identify the extraneous information. So it is often helpful to draw a single pencil line through any information you identify as not needed. This prevents you from using that information in your setup, because sometimes the word problems or the story problems will give you additional information that you do not need. So I do not do the estimate, so I skip that. Step 6 is use the ratio proportion method to solve for x. When using the ratio proportion method to solve your problem, place the physician ordered dose on the left side of the proportion and the pharmacy on hand ratio on the right side. So round your answer to the appropriate number of significant figures. So weights are typically rounded to the nearest whole milligrams, and volumes are usually typically rounded to the nearest tenth of a milliliter. So here's an example. You have a physician has ordered 370 milligrams of a drug, and you have 10 milliliters vial of solution containing 250 milligrams and 3 milliliters on hand. How many milliliters will you measure out? So first, and I'm going through this, step 1 is a physician has, this is read through the entire problem, which we just did. Identify what the question is asking for. It's asking for how many milliliters. So it's asking for x milliliters. This becomes the variable x labeled and the unit you're looking for, such as x milligrams or x milliliters in this case. So we need to find out how many milliliters, so x milliliters is the unknown. Step 2, identify the prescriber's order. Circle the dose ordered by the physician. So it would be The physician orders 370 milligrams of the drug. Um, Step 3, identify the appropriate stock available in the pharmacy. Underline this information. So we know that on hand we have 250 milligrams per 3 milliliters of the drug. Next, you have a physician. Step 4 is identify the extraneous information, draw a line through it. So we know that the 10 milliliter vial has nothing to do with what we're trying to solve. So we draw a line through it. Step 5, you can estimate. I don't like to estimate, so I always skip by that part. Step 6, use the ratio proportion method to solve for x. Again, you have x milliliters, because we're trying to find x, over 370 milligrams. That's what the physician wants. What we have on hand is 3 milliliters or 250 milligrams. Again, the denominators must match the units, milligrams. Top one's milliliters. Then we cross multiply. X times 250 would go on the bottom, 250. Then you want to take the next one. It's 370 times 3 is 1,110. And then you're going to divide it by 250. And you come up with 4.44. And then you can round your answer to 4.4 because you want to do it to the nearest tenth. Okay, so now to do some examples out of your book. If you go to page 91 in your book, let me do this for page 91, and we'll do number 1. So you're going to calculate the following doses using the ratio and proportion method. For number 1, it says a patient has a prescription for 30 milligrams of a drug the pharmacy has a partial container of 7.5 milligram tablets. How many tablets will the patient need? I'll abbreviate patient PT, patient need. Okay, so we know what we're trying to find is X tablets. So we set up a ratio proportion problem. X tablets, and the doctor has written it for 30 milligrams. Okay, we know what we have in stock is 7.5 milligram tablets. And usually when you say that, it's 7.5 milligrams per one tablet. Okay, so it'd be 7.5 milligrams. Oops, that should go on the bottom. 7.5 milligrams per one tablet. Okay, again, double check your units. If you noticed before, I tried to almost switch them around and I caught myself. So make sure you put tablets on top. The tablets have to be on the other side, on top. Milligrams on the denominator or the bottom on one side must be that on the other side. So then you want to cross multiply. X times 7.5 is 7.5, and it always goes on the bottom. 30 times 1 is 30. 30 divided by 7.5 will equal 4 tablets. Okay, next we'll do number 2 as a sample. Again, here you have a prescription order is written. So I'm not going to write the whole thing out, but it's written for 20 milligrams. Okay, so that's part that you circle in your word problem. The pharmacy has on hand, and I'll put on hand, maybe underline it, a 10 milliliter vial of 25 milligrams per 2 milliliters of solution. Okay, and then the 10 milliliter vial you could just mark out because you don't really need it. Okay, so next go on to read the rest of it. How many milliliters? So we have X milliliters. That's what we're trying to find. Will be prepared for this patient. So we know on this side is going to be what the doctor has written. He wants you to find X milliliters, and he's written it for 20 milligrams. And we know we have on hand, this is what goes on hand in the pharmacy. 2 milliliters, 25 milligrams per 2 milliliters. Say we have milliliters on top here, so we're going to put our 2 milliliters here. 25 milligrams, you have milligrams on the bottom, so our 25 would go here. Then we're going to cross multiply. X times 25 would be 25. 2 times 20 would be 40, and it goes on top. 40 divided by 25 would be 1.6 milliliters. Okay, now we'll do some additional problems using the drug labels. So this right here is giving you the problem set drug label for number 6. Okay, so what I'm going to do is I'm going to go through here and I'm going to read off what the problem says. And then I'm going to just write the information in my ratio proportion as we do it. Okay. So first, a patient is to receive 18 milligram dose of hydroxyzine. The pharmacy has the following medication available. How many milliliters? So X milliliters will be prepared for this patient. So we know that the doctor wants an 18 milligram dose. Okay, this is what we'll have in stock. So that would go over here. So if we have milligrams on the bottom, the 25 milligrams goes on the bottom. Milliliters on top, and that's 5 milliliters. Then you just want to cross multiply. X times 25 is 25. X, whatever you multiply the X by, always goes on the bottom in a ratio proportion. Then you have 18 times 5 would be 90. 90 divided by 25 would be 3.6. And then it's milliliters because you were trying to find milliliters. The actual drug labels, I think it makes it easier to do the problem set questions. Okay, I'm having some problems with my computer, so I'm going to reset this real quick. Okay, I apologize about that. I'm having some problems with my computer freezing up on me, so I apologize. This recording is a little messed up, but it just has those little stops in the middle of it, and then I start back, so I apologize. Okay, so this problem set is question. Okay, I apologize again. That hopefully I want to get through a couple more examples here before my computer acts up again. So I apologize about that. But this one right here is question number 10 off page 92. So if you look at question 10, it says a patient was given 2 milliliters of gentamicin, shown in the label below. How many milligrams were given to the patient? Okay, so you want to find X milligrams. And we know it's 2 milliliters was given to the patient, or what the physician wants the patient to have. So over here you want to put what you have on stock. So your stock, you have 40 milligrams per 1 milliliter. So your 1 milliliter would go down here on bottom because that's where your milliliters are. Milligrams would go on top, so 40 milligrams. Then you're going to cross multiply. Whatever you multiply the x by always goes on the bottom, so that's 1x, or you could just say 1. 40 times 2 would be 80. 80 divided by 1 would be 80 milligrams. Okay. This one is number 18 off of page 92. Okay. So this one is saying a patient is to receive 2,000 units of heparin. Okay. Use the label to determine how many milliliters. So X milliliters, we know they're receiving 2,000 units, and we always write units out. Okay. Your bottle contains 5,000 units per milliliter. So if I told you if it just has milliliters, it's just 1. So 1 milliliters goes on top because your milliliters is on the top. Units is on the bottom, so you're going to put units there, and it's 5,000. Cross multiply, x times 5,000 is 5,000. X, because x always goes on the bottom. And then 2,000 times 1 is 2,000. If you take it, you can simplify it by taking off your zeros. And then 2 divided by 5 would equal 0.4 milliliters. Okay. And so I think that's pretty good right there on giving you some examples of those problem set drug labels. If you have any questions and need me to do additional practice problems for you out here, if you email me and let me know, I can get you to come in my office and I will show you in person how to do those.